Right, I'm going to consider a couple of number theoretic functions. There's quite a lot of these, or 5 or 6 of them, but I'll take them one at a time. I'm going to consider the function tor, sometimes called function d, equals the number of divisors. Number of divisors function. I get the impression that tor is the standard notation and d is a newer notation, but anyway. So tor of n equals the number of divisors of n, including 1 and n, conventionally. Including 1 and n, conventionally. So let's work out tor of 12, or d of 12, depending on which notation you subscribe to. Well, we can just calculate it like this. We've got 1 goes into 12, 2, 3, 4, 5 doesn't, of course, 6, and 12 itself. So altogether you've got 1, 2, 3, 4, 5, 6. So tor of 12 equals 6. Number of or d of 12 equals 6, I guess. So let's work out tor of, let's say, 16. 1, 2, 4, 8, and 16 itself. 1, 2, 3, 4, 5. So just a couple of observations. It's worth getting to grips with this function. If p is prime, it should be pretty obvious that tor of p equals 2. Brilliant. What about if n? What about tor of 2 to the power n? Well, the numbers that go into it are 1, 2, 2 squared, 2 to the r, all the way up to 2 to the n. So there's n plus 1 of those. That's nice. Okay, well, that's great. So how can we do it in general? If we get a number n and we write it in terms of its prime factors, we can always do this by the virtue of the fundamental theorem of arithmetic. P1 to the alpha 1, P2 to the alpha 2, all the way up to PR to the alpha r. Well, let's just have a think about that. How do we write down the total number of factors in this number? Well, we can choose the power of P1 can either be 0 or 1 or 2 or alpha 1. So altogether, we've got alpha 1 plus 1 choices there, times, here's alpha 2, and the power of P2, it can be P2 to the power 1 or 0 or anything, or 0, 1, 2, all the way up to alpha 2. So you've got alpha 2 plus 1, and so on. So if you've got n equals this thing here, oops, I mean to do that, then this implies that tor of n equals alpha 1 plus 1 times alpha 2 plus 1 times all the way up to alpha, what was the top one, r, equals the product from I equals 1 to n of alpha I plus 1. Okay, and that turns out to be quite useful all over the place. So straight away we can see it. Let's work out what tor of, let's say, 180 is. What are the prime factors of 180? Well, it's equal to 18 times 10, and that of course is 2 times 9. Sorry, that's 2 times 3 squared times 2 times 5. That's the 10 there. That's the 18. So it's 2 squared times 3 squared times 5. So therefore, tor of 180 is 2 plus 1 for this 2 here, times 2 plus 1 for this one here, times 6, because it's, oh no, sorry, it's the power, 1 plus 1, which is 2. So it's 3 times 2, which is 18. There we go. So tor of 180 equals 18. Is that right? It doesn't look very many to me. Let's just verify that. Let's say it's 2 squared times 3 squared times 5. Tor of 180 is 18. Well, it is, isn't it? Well, we can think about it. It's 2 squared times 3 squared times 5. So you've got 2 combinations there because you can either have a 5 or not. You've got 3 there because you can either have 1 or 3 squared. And you've got 3 combinations there as well. So it's 18. Just looks like a bit of a small... It's a very round number. I'd expect it to have more than 18 divisors. But, well, it is what it is. There you go. Tor of 180 is 18. I'm going to stop there.